Hey everyone, welcome back. I hope you're all doing well. In this video, we'll walk through an illustrative example of how to update changes in a precedence diagram and Gantt chart schedule. Alright, in this example, you're given a precedence diagram schedule which will be shown shortly. As of the end of day 18, the project superintendent has reported several updates. Activity C is expected to start in 3 days. Activity F has already been in progress for 5 days, but now it requires an additional 3 days beyond its original duration. Delivery problems have delayed the start of Activity I by 10 days. Activity G is tied to Activity I. It must start at the same time as Activity I, but it cannot finish until 2 days after. Activity I is completed. Meanwhile, Activity E remains on schedule with no changes reported. With this information, we'll now look at how these updates affect the precedence diagram and the Gantt chart. Here's the original or baseline network schedule of the project before the update period. It includes 11 activities labeled from A to K. The activity durations, along with their early and late start and finish times, are shown within each activity node. Now, let's go through the updating process step by step. First, we need to review the information provided and determine the updated schedule for each of the reported activities. As mentioned in the problem statement, we have data available up to the end of day 18. So, the status date is set to day 18. Then, Activity C will start in 3 days. Since our status date is day 18, Activity C will start on day 21, which is 18 plus 3. Next, for Activity F, it has been in progress for 5 days. This means Activity F must have started 5 days before the status date, so it started on day 13, which is 18 minus 5. It also says that Activity F needs 3 more days beyond its original duration. So the new total duration for Activity F is 21 days, the original, plus 3 extra days, which gives us 24 days. For Activity I, it's delayed by 10 days due to delivery problems. The original start was on day 47, so we add 10 days to that, and the new start for Activity I will be day 57. For Activity G, it must start at the same time as Activity I. So there's a new start-to-start SS relationship between G and I. It also says that G cannot finish until 2 days after I finishes. This creates a finish-to-finish FF relationship with a 2-day lag between G and I. Lastly, Activity E is on schedule, so no changes are needed for this one. Alright, let's go ahead and integrate the changes into the network. The changes are summarized on the left, while the figure on the right presents the complete solution. Now, let's walk through the entire process, including incorporating changes, performing the forward pass, completing the backward pass. Starting with Activity C, its new start is day 21. Since there's no change in duration, we simply add 18 days, which gives us a finish on day 39. Next, Activity F has a new duration of 24 days. It starts on day 13, and adding 24 days brings its early finish to day 37. For Activity I, the updated start is day 57. However, since it also depends on activities D and H, whose finishes we don't know yet, we'll temporarily set its start at 57 and adjust it later if needed. Now, there are 2 new dependencies between G and I, start-to-start, SS, and finish-to-finish, FF, with a 2-day lag. These need to be incorporated into the network. Activity E remains unchanged, meaning its start and finish will be the same as in the original schedule, starting on day 16 and finishing on day 33. Now that we've added all recorded changes, let's proceed with the forward pass. Activities A and B occur before E, which starts on day 16. The status date is day 18, so A and B have already been completed on schedule, meaning we don't need to calculate them. We've already determined the values for C, E, and F. Now let's move to Activity D. It depends on the finishes of both E and F. Taking the later finish date, which is 37, D will start on day 37. With a duration of 8 days, it will finish on day 45. Next is Activity H, which depends on the finishes of both C and F. The later of the two is 39, so H will start on day 39. Adding its 10-day duration, it will finish on day 49. Activity J follows H, so it must start on day 49. Adding its 9-day duration, it will finish on day 58. Now, for Activity I, we determined earlier that it must start no later than day 57 due to material delivery delays. Checking its dependencies, we see that it also relies on the finishes of D and H. The later of those two is 49, which is earlier than 57, meaning we don't need to adjust I's start. Adding its 6-day duration, I will finish on day 63. Activity G depends on both the finish of D and the start of I. The later of these is 57, so G starts on day 57. Adding its duration, it will finish on day 68. We also need to check the finish-to-finish, FF dependency from I, which means G's finish must be at least 2 days after I's finish. I finishes on 63, plus a 2-day lag, bringing us to 65. Since 65 is earlier than G's calculated finish of 68, no adjustment is needed. Lastly, Activity K has 3 predecessors. The finishes of G, I, and J. The latest of these is 68, so K starts on day 68. Adding its duration of 4 days, it finishes on day 72. This means the updated project duration is now 72 days. Comparing this to the original duration of 60 days, we can see the project is currently delayed by 12 days. With the forward pass complete, the next step is to calculate the late start and late finish for each activity using a backward pass. You can review the PDM video and try calculating it yourself. Here's the solution for reference. Now, let's make the bar chart schedule from the precedence network. An updated bar chart schedule typically includes both the baseline and the updated version on the same chart, making it easier to see changes and delays. First, we establish the baseline schedule. This represents the original network before any changes occur, based on the early start and early finish times from the initial plan. Next, we add the updated schedule. To do this, we plot the adjusted activity bars in blue, reflecting the revised early start and finish times from the updated precedence diagram. And here's what we get. Now, we add the status date on the chart, which marks the point up to which data has been recorded. In this case, the status date is day 18. This updated schedule gives us several key insights. For instance, just by looking at the blue bars, we can quickly identify which tasks are completed and which ones are still in progress. Activities that are entirely to the left of the status line are fully completed. Those that extend beyond the status line are still ongoing. The portion of a blue bar that falls before the status line represents the percentage of work completed. Take activities A and B, for example. Their bars are completely on the left side, meaning they are 100% finished. Meanwhile, activities like E and F are partially completed, as their bars are cut by the status line. Activities like C and D, on the other hand, are entirely to the right of the status line, meaning no work has started on them yet. We can also measure delays by looking at the gaps between the original and updated bars. The difference between the end of the black bar, the original schedule, and the end of the blue bar, the updated schedule, shows how much an activity has been delayed. Finally, to determine project-wide delays, we look at the gap between the last black bar and the last blue bar. In this case, that delay is 12 days. With this visualization, we can clearly see how our schedule has changed and what adjustments may be needed moving forward. When you find your project falling behind schedule, first, you need to measure how far behind you actually are. Understanding the extent of the delay is the first step toward recovery. Next, you identify the major causes. Is it a resource issue, a delay in material delivery, unforeseen site conditions? Pinpointing the root causes will help determine the best course of action. Now, you outline a plan to get back on track. This could include strategies like working overtime, adding extra shifts, increasing labor resources, or scheduling tasks to run concurrently. The key is to act quickly and efficiently to minimize further delays and keep the project moving forward. Alright, that's it for this video, where we walked through an example of how to update a precedence network and its bar chart schedule. Thanks for watching, and we'll see you in the next video. Goodbye!